Okay. 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 This is a technique. Menjawab for the Science SPM. Okay. The latest one, 2025. 2025. Okay. Look at here. The diagram. Look at the first question. This is bahagian A. The structure. The diagram 1.1 show an experiment for a type of the pure matter and alloy. The pure matter and alloy. Yeah. So look at here. This is the ion ring. This is the steering. So this is a pure matter. Okay, this is a alloy. Alloy. Yeah. This is the alloy. Yeah. Okay. So you see, after we put 4 wicks, okay, in the water, okay, and you can find the brown layer form. Okay, and in the water you also can find the brown precipitate. It's a mendahkan. Okay, whereas the alloy ring remain unchanged. So the question based on the experiment, okay, state one manipulator variable. Manipulator variable is a cause of the result. Apakah penyebab eksperimen ini? Okay, so you see the different thing you use. Okay, you just put iron, ring, and steering. You put the word and you cannot put the word or. Okay, you cannot put the word or. Or cannot. Must put the iron ring and steering. Or you also can put what type of ring, type of ring, type of ring also can. Because the type of ring which causes the result become different. Okay, this is the A. Okay, next we go to the B. Yeah. B. State one observation after 4 weeks on the test tube P. Test tube P, yeah, not Q, sorry, it's P, yeah. So state one observation after 4 weeks on the test tube P. So you only choose these 2 answers. P, yeah. Ion ring has brown layer. Ion ring has brown layer. Okay, we refer to the diagram. Okay, what you can see, ion ring has brown layer. Okay, or you can say that the ion ring, okay, the brown precipitate form in the water. Okay, brown precipitate form in the water also can. Brown precipitate form in the water also can. So that means what you see and what you write. Okay, what you see and what you write. Okay, next we go to the state one inference. Okay, one inference of the observation. Inference means what? Inference means inference means reason. Why? Okay, this is your observation actually. Ion ring has brown layer. Okay, this is your observation. Okay, the observation from here. Okay, from here, then you add the word because what? Because the pure matter rush, berkarat. Okay, if you choose the first observation, so you choose this one. Okay, the second one, if your answer is brown precipitate form in the water, so you must put brown precipitate form in the water because what? If a reason, because pure matter rush. Okay, so you must add the because. So the first part is the what? Observation. Okay, the observation must based on the what you put there. The observation here must match observation. Okay, this is the inference. Inference means you give the reason why your observation is like that. You give the reason why. Okay, next we go to the B. Diagram 1.2 show the test tube P after being left for the 8 weeks. 8 minggu, selepas 8 minggu. So you can see that the brick brown precipitate is a brown color solid which are unable to dissolve in the water. We call brown precipitate. So the means the brown precipitate is more. So state the relationship between the number of days and the amount of the brown precipitate on the ion ring. So you can see is the more, the more. So in your answer, they ask you to state the relationship between the number of the day. Your answer must have the number of day, amount of the brown precipitate. Your answer must have these two things. Okay, look at the answer. The more the number of day, the more the amount of brown precipitate on the ion ring. Okay, this is the answer. Okay, next. We go to the next C. The following statement showed a conclusion for the experiment. Alloy is resistant to corrosion. Tahan kakisan. Conclusion. So nyatakan based on the diagram 1.1 state 1 evidence that show the conclusion is accurate. Okay, we must back to the diagram 1.1. What evidence show that the conclusion is accurate? That alloy tahan kakisan. Alloy is resistant to corrosion. So look at this. This is the diagram 1.1. So you see, iron ring remain unchanged, no change after 4 weeks. This is the evidence. Okay, this is the evidence. Evidence. So you just put steel ring did not show any changes after put into the water for 4 weeks. So this one you must find out the evidence from the diagram based on the diagram 1.1. Okay. Okay. I will go to the next question. Next question. Second question. Okay. Diagram table 1 show the experiment result to the study relationship between the mass and the inertia. Inertia, mass is jisim. Inertia is inertia. Like inertia is how the object maintain its original speed for a while. Okay, then only you will continue with the new speed. So the very short time to maintain the original speed, okay, the one we call as inertia. Okay, inertia. Okay, look at here. The jisim plasticine, the mass of the plasticine we use is 20, 30, 40, 50, 60. The time taken for the 5 complete oxidation. Okay, oxidation, let's say this is the oxidation. Okay, it's 26, 30, 31. Okay. Okay, look at here. Diagram 2 show the reading of the stopwatch of 5 complete oxidation of the 50 gram plasticine. Okay, oxidation. So you based on the stopwatch, it's 41. 41, so you put 41. For stopwatch, you only can put the round number 41 or 42. Because from the stopwatch, you're unable to find the 41.5, 41.8 cannot. 42.5 also cannot. Must be the round number. But if you use thermometer, thermometer cannot. Thermometer also cannot. 35. Okay, 35.2 cannot because the thermometer only you can read the reading 35. You cannot read the 35 point. Okay, cannot. I think I do the mistake. This one, a stopwatch. Usually inside also can. Inside got a small reading can. 41. I might just put 41 easier because I already show you very easy 41. Okay, for thermometer cannot. But for this diagram, they already show you very clear 41, just you put 41. Okay, you just put 41. Okay, next we go to the next. Predict the time taken for the 5 complete oscillation if the mass is 25 grams. So what will happen if the mass is 25 grams? So 25 grams is between here. Right? So 25 grams. So that means you must use a 31 minus 26 lah, divided by 2. Okay, it's about 31 divided by 5. That means is 28.5 lah. Okay, 28.5. You take a middle, tengah-tengah. So accepted number is 25. Sorry, 28, 28.5, 29. Okay, the accurate is this one lah. We ambil the tengah-tengah one. Okay. Okay, next we go to the base on the table 1, draw a line graph. Line graph. So you just connect all the point and then use a free hand to connect. Okay, connect all the point and use a free hand. And don't connect the graph to the 0. Cannot. You don't connect the graph to the 0 because we got no data 0. We got no data 0. You don't connect to the 0. And we got how many type of graph we have? Actually, in our syllabus, we got 3 type of graph. Okay, the first is line graph. Line graph. Okay, this one. The first one is line graph. Okay, the second one is bar chart. They ask you to draw the bar chart. So the bar chart is like this. They got a space between. So the space here, and space here must be the same. Okay. Okay, the third one is we call as histogram. Okay, third one is histogram. Okay, must be connected together. Okay, only 3 graphs in your syllabus. Only these 3 graphs in your syllabus. Okay, come back. You draw the graph, just connect all the points. Okay, just connect all the points together and no need to draw to the 0. Okay, no need to draw to the 0. Okay, next we go to the next. The following is a statement related to the experiment. As the mass of the processing increases, the time taken for the 5 complete oscillation increases. Okay, so to prove, based on the experiment, how can you prove the statement? How can you prove the statement? When the mass of the processing increase, the time taken for the 5 complete oscillation increases. So how you prove? How we prove? How we prove? Okay, you can see when the mass of the processing is 60, so the time taken for 5 complete oscillation is longest. So this is the proof. We must based on the table 1 is a proof. So you put here, okay, time taken for 5 oscillation, complete oscillation is longest, no longer. You cannot put longer. Longer is wrong. Okay, when the mass of processing is 60 grams, you choose the highest one. Okay, you choose the highest one. Okay, these are finished. Okay, these are also finished. So I repeat again. They say as the mass, the following statement is related to the experiment. As the mass of the plasticity increases, the time taken for the 5 complete oscillation increases. Okay, for complete oscillation increases. So based on the experiment, how can you prove the statement? When the mass increase, the time taken is increases. So we use the data here. We use the data here, the highest and the highest. Okay, highest and the highest. Okay, I repeat that. Selection. Okay, we try to go to the experiment and see. Okay, this is how we carry out the experiment.
Adakah desain objek mempengaruhi kinerja objek tersebut? Dan hipotesis untuk eksperimen sudah memiliki ialah semakin besar desain tentang objek, semakin besar kinerja objek tersebut. Seperti biasa, tiga polymer yang pertama polymer dibandingkan ialah desain plastik di mana kita menemukan 5 desain plastik yang berbeza iaitu 20, 40, 50, 60 dan 70. Kemudian yang bergerak malam lebih berkaitan dan yang dimalamkan ialah panjang tidak gergaji yang berayun dan juga bentuk plastik. Okey, ada radar tadi kita ialah kita gergaji yang radit, plastik dan juga penyimpan elektrik.
Okay, stopwatch. Okay, oscillation. Count how many complete oscillation. Okay, 40 gram. One oscillation I see, oscillation. How many oscillation? Okay, this is how the experiment, you can refer to this experiment. Okay, we come back to the work. Okay, next we go to the third question. A student investigates the effect of oxidation of the pear slide in the different solution as shown in the diagram. It's a white pear slide. Okay, put in the sugar solution for 15 minutes. Okay, the pear slide become brown color. Another one is a pear slide. We put in the lime juice, and then the pear slide remain white after 15 minutes. So from this experiment, They ask you state one responding variable. Responding variable. What is meant by responding variable? Responding variable is a result of the experiment. You see the changes color of the pear slide. If you put the changes color of the pear, this one is wrong. Pear cannot. It must be the pear slide. Pear means it haven't cut yet, so the one you cannot see the color. Okay, you cannot see the color, so cannot. Okay, next we go to the. Okay, from this experiment, we can see the manipulated variable is the sugar solution and the lime juice. Or you also can put type of solution. Okay, manipulated variable type of solution. Okay, why when they put in the lime juice the pear slide remain unchanged in the white color? Because the lime juice contain antioxidant. Okay, antioxidant. Okay, the constant variable type of pair we use, duration of time we immerse in the solution. So both also we immerse 15 minutes. 15 minutes. Okay, next question. Okay, we will see. State one way to control the variable in the 3-1. 3-1 is the responding variable just now, the changes of the color of the pear slide. So how you do is observe the changes of color of the pear slide in the solution after 15 minutes. You use the word observe. If the way you obtain the result involve the apparatus, example involve the stopwatch, so you must mention stopwatch. If you obtain the result using ruler, you must put the apparatus ruler here. So in this case, it didn't involve any apparatus, so we just use the word observe. Okay, next we go to the nyatakan. State the operational definition for the oxidation process of the slide. So in your answer, this one must be the first one. They ask you to define the word oxidation process of the pear slide. Okay, they ask you to oxidation process of the pear slide. So you must define the word. Okay, how? Okay, look at here. Oxidation process of the pear slide is a what? It's a process of changing color of pear slide from white to brown. So this is what you see. Of course, the process you can also change to you can also change to substance. You also can change to condition. Okay, so which one is suitable lah? Okay, the word process is a what? It's a process, it's a substance, it's a condition, or what? Of changing the color of the pear slide from white to brown. This is what you see. What you see, when what you do, immerse in sugar solution for 15 minutes. For 15 minutes. Okay, because it changed from white to brown. Okay, in the 15 minutes. So we usually use the what the which one changed, the remain unchanged one. We use another one which is a change one. Okay, this is a formula, the structure. Okay, when you answer this type of define offer of say the operational definition, you use this structure. You just isi tempat kosong. Okay, it asks you to define this word, right? Oxidation process of the pear slide. So you just put in the first of the sentence. Then using this structure. Okay, using the structure. Okay. Actually, it's like this. Istilah, the word they ask you to define is what? It's a process or condition or substance, okay, which causes what you see, okay, the color change of the pear slide when what you do when you immerse in the sugar solution for 15 minutes. Okay, this is what oxidation. You using this format. Okay, using the format, you are able to answer this type question. Okay, using the format. Wait, I give you. Don't use your own sentence. You use this format. Okay, next we go to the next. Nyatakan satu kesimpulan. State 1 conclusion. Okay, conclusion is the solution which contain the additive oxidant able to inhibit the oxidation process on the pure slab. Okay, this is the new one. All the vitamin A, vitamin C, vitamin E is antioxidant. Okay, look at the B one. The student prepare a control set by putting a slide of the pill in a beaker without any solution at the beginning of the experiment. Okay, what's the function of the control set? Okay, I put just now in the sugar, another one in the lemon juice, lime juice, now in the empty one, kosong one. Okay, empty one, kosong one. You put the slide of the pill inside. Okay, the first one is sugar, right? The second one is lime. So the question asks you why we need to prepare the kosong one. So the answer is as a comparison set. We want to compare, okay, to the changes of color of the pill slide when immersed in the sugar solution and the lime juice. We want to compare the three. Okay. So we go to the last question. Last question for the structure. Last question. Okay. So this is BOD, BOD. Okay, diagram 4.1 show two reading digital stopwatch of the time taken to decolorize 1 centimeter cube of the methylene blue solution for 2 water samples. Okay, if the water very polluted, usually we use 250 centimeter cube. We will put 1 drop of the methylene blue, not 1 drop, 1 centimeter cube of methylene blue. Select the blue methylene you put inside here. Okay, if the water very polluted, so the methylene blue will become decolorized. Decolorized means become colorless. Okay, become colorless very fast. If they become colorless very fast means the BOD very high. When the BOD very high means the biooptical demand is very high, means the water sample is very polluted. Okay, so you must remember short time to decolorize means what? Means polluted. Okay. So example, you see, 60 minutes and 90 minutes. Which one is polluted? 60 minutes is more polluted. Okay. Water, river water, and the lake water. Which one is more polluted? Of course, the river water more polluted than the lake water. Okay, next. So you can see from this experiment, the responding variable is what? It's the time taken to decolorize 1 centimeter cube of the methylene blue solution. This is the responding variable. Okay. And then what is the manipulator variable? Type of the water sample or river water and lake water. River water or lake water, because you see in this experiment, 2 types of water we use. River water and lake water. You just put manipulator variable, river water and lake water. Constant volume of the water sample. Constant means same one, same. Apa yang sama. We use 250 and 250. 250 and 250. So this is the constant variable. Okay, next. Okay. Based on the diagram 4.1, take observation for the river water. Observation for the river water. What's the observation for the river water? River water refer to this one. Observation 60 minutes. The time taken to decolorize 1 centimeter cube or 1 ml of the methylene blue solution is 60 minutes for river water. You must mention the value. Kena ada nilai 60 minit. State one reason why. This is 60 minutes and then this is 90 minutes. So why? Because river water is more polluted. You can use more polluted because in this only 2 water sample you use. One is river water, one is lake water. So you can use more. If more than 3, you must use most polluted. M-O-S-T. Most polluted. Okay, but now only 2, you can use more polluted. Okay, next, state one way to control the constant variable. One way to control the constant variable. So you see, the constant variable is the volume of the water sample. Constant variable means what you use same for both. What you may maintain the same. Okay, the answer is by using the same volume of the water sample, that is 250 centimeter cube. Okay, must mention the 250. Or you can use by using the same volume of methylene blue solution, that is 1 centimeter cube. You must mention the 1 centimeter cube. Okay. Okay, next D. Diagram 4.2 show the time taken to decolorize 1 centimeter cube methylene blue solution for the water sample M. M only use 32 minutes. 32 minutes. Just now I say short. The time is short. When the time is short, means what? Means more polluted. Short time means more polluted. So they ask you, based on the information in the diagram 4.1 and 4.2, arrange the water sample according to the level of water pollution in the ascending order. Tertib menaik means more polluted. Okay, here is less polluted, and then go to the more polluted. Okay, so water sample M is usually the short time, only 32. So you put is the most polluted, followed by river 60, and the lake is 90. Okay, it's a more, it's a less, it's a least polluted, it's cleaner. Okay, next. Lake water is safer to be consumed because it is less polluted. Lake water is less polluted. Based on the experiment, take one evidence that can support the experiment. One evidence that can support the experiment. So one evidence is what? Lake water is less polluted. So less water. The time taken to decolorize 1 centimeter cube of methylene blue solution for the lake water sample is longest. That is 90 minutes. So this is a proof that the lake water is less polluted because it's using the longest time, which is 90 minutes. Okay, 90 minutes. Okay, complete. This is the part 1 of the structure. Okay, I hope can help you to answer your science SPM. Okay.